So hello everyone, welcome back to the channel. Today we are going to solve the problem partition the array. So given an array of integers, the task is to partition the array into four non-empty contiguous subarray PQRS such that each elements of the array should be present in any subarray. Let WXYZ be the sum of the elements in the PQRS respectively. Find the smallest absolute difference between the maximum and minimum among WXYZ. So let's understand the question. So what we are given? We are given an array and we need to divide this array into four parts P, Q, R, S. Okay. Now, let's say the sum of all the elements in P array is W. And let's say the sum of elements in Q is X, and in R, Y, and in S, Z. Okay. These are the sums of the element in these subarrays. Okay. Now, what we do, we will take the maximum out of them. We will take the minimum out of them. We will subtract. We will subtract, and this is the difference that I got. Absolute difference we have to get. Okay. So now we have to do minimize this absolute difference. So we have to make such a partition such that this difference is minimized. So let's understand with an example. Let's say we are given this 4, 2, 2, 5, 1. So let's say I partition here, here, and here. So we have four subarrays. Now within these four subarrays, sum is 4, sum is 4, sum is 5, sum is 1, and absolute difference will be 5 minus. This is maximum, this is minimum out of them. So this will be 4. Okay. Now let's try another configuration. 4, 2, 2, 5, 1. So let's say I write this, this, and this. This is 6, this is 2, this is 5, this is 1. What is the maximum out of them? 6. Minimum is 1. So absolute difference is 5. So I will say, okay, this is greater, this is smaller. So I will say, okay, that answer is 4. But when you will try many configuration, you will get it's 4. We have 5 and many greater element can arise. Okay. Okay. So now let's, how can we approach this question? So for approaching this question, we can apply linear search like normally we can try to partition the array by taking the three loops. Okay. Nested loop for I is equals to 0. Like I can take first array till I can take second array till j, and third array till k, but it will be big of n cube. Okay. We don't want this. We don't want this. We want something big of n log n. So for reaching the n log n solution, let's get some intuition that what we are going to do. So let's change the question first. Let's partition the array into two parts. Let's partition array into two parts such that absolute difference is minimum. Okay. This is the question that I'm changing. So let's change the question. So let's understand the intuition of this question. So just don't think about that question. I have to divide into four parts. So I'm changing the question that let's partition that into two parts, and we have to get minimum absolute difference within these two parts. Okay. So what we can do? We can take first partition till here and second partition till here. So first partition will be 4 and second partition will be 2 plus 2, 4, 4 plus 5, 9, 9 plus 1, 10. So second partition will have 16. So I will say 16 minus 4 is equals to what? 12. Okay. So in similarly way, what we can do? Second part of subarray like this, and third and first like this, and second like this. This will be 6, 7 plus 1, 8, 14. So I will say, okay, 14 minus 6, it will be 8. Similarly, I can shift this first partition more ahead, and this will be 8, and the 5 plus 1, 6, 12. So this will be 12 minus 8 is equal to 4. Okay. So similarly, we can apply other partition like this. 4, 5, 6, 7, 8, 13, and this is 7. So 13 minus 7 is 6. Okay. Now, similarly, if I do other last partition, that will be 4 plus 2, 8, 8 plus 13, 14, 40 minus 6 is 8. So I will say out of them, minimum is 4. So answer is equal to 4 here. Okay. We are sure. Now, can we do partition like this? This and this? No, this is empty. This is not a subarray. Okay. So I will say, okay, empty subarray should not be taken. So we can say that we will do partition till here. That we can take 0, or we can take 1, we can take 2, we can take 3. So other will be left, obviously. We can take 4, other will be 5, like this. Okay. So, but can we do something optimized? Yes, we can use linear search. We can use binary search. How can we use binary search? So let's try to understand how can we use binary search. So you know that I want the sum of first part and second part. So should I need to compute it again and again? No. So for that, what I can pre-compute that. How? I can maintain a prefix sum. Okay, so 4, 6. So this will be 6, this will be 8, this will be 13, this will be 14, and this will be 20. Okay, so this is a prefix sum that I can maintain. Now, what we can do? We have to apply binary search. So should I apply binary search till 5? No. Why? Because in the first part, we can take only till 4. So I will apply binary search only till 4. Okay. So I will say, okay, because we can take partition till 0, first like 1, first like 2, first like 3, first like 4, only till that. So I will say, okay, start is equals to 0 and end is equals to 4 initially. Okay. So I will say, okay, mid is equal to start plus end by 2. That is 0 plus 4 by 2. It will be equal to 2. So, okay, then I will say I can take elements till 2. So what is the sum till 2? Obviously 8, because this is what 8 sum depicting. It says that sum till this is 8. Okay. So, okay, then I will say that for the first partition sum is 8. And what is the sum for second partition? Because we have 20 till this now. So 20 add this added a. This 8 is added in 20. So I have to subtract this 8 from 20. So I will say, okay, 20 minus 8. I will subtract. This is the mid now. So I will say, okay, array of high. That is prefix sum of high minus prefix sum of mid. Okay, this will be the second sum. And the first sum is directly prefix sum of what? Mid. Okay, this is the sum. Okay, so second will be equal to what? A 20 minus 8. That is 12. Obviously, you can see it will be 12. Okay, so okay, so currently the absolute difference is for current partition, it will be 4. 12 minus 8, 4. Can we minimize this 4? So how can we minimize it? Just understand one thing. This is the first partition. Let's say this is sum 1. This is the second partition. This is sum 2. So I am subtracting sum 2 minus sum 1. So in that case, let's say I have 13 minus 8. Let's say I have 13 minus 5. It will be 3. It will be 8. Why I'm getting 8 here? Because this 5 is smaller. This is because this is minimum. That's why it is generating greater difference. Because 13 and 5 are greater gap. But if I increase this 5 to 8, this will become 3 because 8 is greater number. So that will subtract 13 from 13 more. So it will generate smaller difference. So that means whichever element is smaller, either sum 2 or sum 1. Because let's say in the absolute difference, I can do sum 2 minus sum 1 or I can do sum 1 minus sum 2. So what will be my approach? If sum 1 is less than sum 2, so I will increase this sum 1 such that this difference is minimized. Similarly, if sum 2 is smaller, I will increase this sum 2 such that this difference is minimized. So what is the main thing for binary search? That we have to increase the minimum sum. Whatever is the minimum sum, just increment this. So let's say I made the partition till this. Understand? Let's say I made the partition till 2. So I will say make the partition till 3. Why? Because this part was smaller. So if I increase this, maybe this difference is minimized. Okay. So this is the approach. So what I will say, let's shift what we do for increasing the partition in the binary search. S is equal to mid plus 1 and n will remain as it is. That is n minus 1. Like n minus 2 it was because I'm taking 4. Okay. So now S is equals to n minus 2. So what will be start currently? Start will be equal to, this is the first, this is second. Don't confuse this with the start variable. S will be equal to now 3 and end will be equal to 4. So now my binary search lies only here. Okay. So now 3 is, if I take the mid here again, 3 plus 4 by 2, it will be 3. So I can say that I can take partition till 3 and the other till like other will be 4 and 5. Okay. So I have the sum 13 and here I have the sum 20 minus 13, that is 7. So 13 minus 7 is 6. Obviously this is greater difference. So I will say yes, it is greater. That means this part is smaller. This part is greater. So my main aim is to increase this smaller because now this becomes smaller, I will increase this. So I will say, okay, and will shift mid minus 1. Okay. So start will be 3 and end will be equal to, because for 3 and is equals to 2. So it will break out of the loop. So absolute difference will be 4. So the main intuition behind the question was partition the array into 2 parts. Now let's understand the approach. How can we make this question jump to 4 parts? Okay. Now, so just let me again repeat this thing. Let's say my sum 1 is greater. Whatever is greater, whatever is smaller, I have to increase this so that this will become closer to sum 2. Let's say I have 13, let's say 5. So I will try to increase this 5 to 8 such that this will become closer and generate minimum difference. This will generate minimum difference because I've increased the smaller number. This is the intuition. Okay. So now the approach clearly by dry running the approach. So there is a pseudocode that I've written. So what I will be going to do, I will be going to first, because I want four partitions. So let's say I have this part. Okay. So first I will do here partition. Okay. Now after that, I will get two partitions. Now within that, I will again do two partitions. So what I will be going to get first, second, this will be already partition, third and fourth. So these four partitions I am able to get. So that is the approach that I'm going to use. So I will say, okay, let's try to first partition the outside array. Okay. So there, so we will not be going to apply. So let me tell you again. Let's say I got this and I got this. Now in so what we are going to do, I will try to make every partition possible outside. And after that, those two partition, I will apply binary search on them. Okay. So this is the approach that I'm going to use. Okay. So let's try to understand like by dry running. Okay. So let's say these are indices 0, 1, 2, 3, 4, and 5. Okay. So why I'm starting from 1 here and why I'm going to L minus 3 here? Let me tell you. If I take partition, let's say here, this will be 4, this will be 6, 8, 13, 14, 21. Okay. Can I partition into two parts? No. I need at least two elements for partitioning into two parts. So that means I will start from 1. Similarly, I am going till n minus 3 because I have to leave at least two elements at the right side for partitioning into two parts. So that's why my loop is running from 1 to n minus 3. First thing is clear, I think. Okay. Now, next, let's try it. Let's try to take this 4, 6. Okay. So in the first partition, let's mark this as first. In the first partition, I have 4 and 6. In the second partition, I have 8, 13, 14, and 21. Now, within this partition, the same I apply binary search that we have done above. Same binary search. And we try to get the minimum absolute difference. Okay, absolute difference. Now, similarly, in the second partition also, we will do this. So we are doing for both the same thing. Now, what we are doing actually, let me repeat again. We are doing actually, we are trying to partition using linear search at every possible point. This, like this. And after partitioning, we get two parts of the array, two subarrays. Now, within these two subarrays, we are going to partition in such a way that the absolute difference between two of them is minimum. So, in this way, we are going to solve the question that after a minimum, now this is the first part, this is the second part, this is the third part, this is the fourth part. And after that, these parts will return some first, second, third, fourth. Now we get to try to get maximum. We try to get minimum. And after that, we will take absolute difference. Now, I don't know. I don't know about outside array. Which partition will give me correct answer? That's why I can't apply binary search here. I can't apply binary search here. I have to try every possible partition because I don't know outside that which two partitions will further divide and can give greater answer and can give correct answer. Okay. So that's all about the approach. This was basic approach. So let's try to understand, try to code it up the approach. Okay. Now, first task was to find the prefix sum first. So I will say prefix sum of n is equal to 0. Okay. So initially all elements are 0. I will iterate the loop. So you will get a better understanding when I coded up this approach. Okay. So if I is greater than 0, prefix sum of I plus is equal to prefix sum of I minus 1. Okay. Now, prefix sum of I plus is equal to array of I. Now, after that, I want to get the minimum absolute difference. So I will say min answer 1e9. And as I already said, I will start the loop from 1 and move till n minus 3 and do I plus plus. And then from the first partition, I will do prefix sum comma 0 to I. And second partition, I will take the two sums. Okay. I plus 1 and n minus 1. Okay. Then now what will be the first partition answer? When I will return in the pair form, fs dot first. Similarly, second partition answer will be fs dot second and long third is equal to ss dot first because from second partition, I'm getting two pair first partition, first sum and second sum. Fourth is equal to ss dot second. Okay. Now what we have to do? We have to find maximum out of all of them. First, comma, second, comma, maximum of third, comma, fourth. Okay. Now, similarly, out of them, I have to get the minimum as well. Minimum of minimum, first, comma, second, because I have to get a minimum out of all of them. That's why I'm doing this. And at the end, we have to take minimum answer is equal to minimum min answer, comma, maximum minus minimum. And at the end, what we have to do? We have to return the minimum answer. So now main thing is this binary search function, as I already told. Now just write it clearly. Now, because this bind search function will be returning two sum, pair long, 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 and solve. This will be the function. Now within this, we are coming with with a prefix sum array. We don't want the array now. We are sending the prefix sum array because we just want the sum of the both partitions. And then we have two starting point and ending point. Okay. Now, what will be the low? Start. High is equals to end minus one. Why? As I already told in the binary search part that I can take only till here because I want at least one element in the second partition. In the second partition, I want at least one element. And in the first partition, I want at least one element. So that's why I will say high is equals to n minus 1. I apply the binary search till n minus 1. Okay. Now, because we are getting the range like start to end. Now, we want that binary search should apply from n minus 1 so that at the last end should also be at least one element is left. Okay. So that is a approach that I'm doing the binary search till n minus 1. Okay. Now, let's say left answer is equal to 0 and right answer as just like greater answer. Let's take 189. Okay. Now, after that, we will apply binary search while low is less than is equal to high as we do. And int mid is equal to low plus high by 2. Okay. Let's check. Is absolute of right answer minus left answer. That means my previous answer is greater than what? The left sum and right sum. What is the left sum? Left sum will be equal to prefix sum of mid minus prefix sum of low minus 1. Why? Why? Let's say my partition is this. Because let's say I partition this greater array into two parts. Now within these two arrays, I am again partitioning. Because let's say here is 0, here is 4, 0 is 5. Let's say here 7, 7. Okay. Now here it will be 0 to 4 and here it will be 5 to 7. Okay. And let's say I partition at 6. So I have to remove the answer before 6. Why? Because before or equal to 6. Why? Because I want only sum against 6 for the second partition. And for the first partition, what I will do? Because I have only 5. So I have to subtract the previous prefix sum from that. Okay. So this is a basic thing that you might know. So left sum is equal to this. But maybe low minus 1 is exceeding the 0. So I have to check whether it is greater than or is equal to 0. So otherwise it will be 0. Okay. Now for the right sum, it will be prefix sum of high minus prefix sum of mid. Okay. Now I will check whether this should be long, long. Okay. And I will check whether the absolute difference currently I'm getting is smaller. Yes. Then I will say, let's store this in our current answer variable. Left answer is equal to left sum. Now I already said, how can we shift them in? If the left sum is less than right sum, that means increment the left sum. So I will say, okay, increase the partition point. Okay. So low is equal to mid plus 1. Else high is equal to mid minus 1. Okay. Now what do we have to return? We have to return the pair of left sum and right sum, which are getting minimum absolute difference. Left answer, comma, right answer. So let's try to compile it in the code and check whether it's working fine. I have taken array. Let's make this ARR. Okay, let's try to compile in the code again. Now, one thing that I've done wrong, what? Let me tell you. Like when I am doing when I have, let's say I have this array, okay? And let's say as I'm starting from, here is a start, here is the end, okay? Now I have low is equal to start and high is equal to end minus 1 as I was doing, okay? So mid will come, mid will say, okay. Now, what will be the sum till midpoint? Prefix sum of mid minus prefix sum of start. Because low can go anywhere. What I was doing prefix sum of mid minus prefix sum of low. That's the row. Okay. So I have to be with the start because this is the sum. Wherever mid will shift, this will be the sum and this will be the sum. So low and high are only for traversing the array for making the partition. So that's why this I have done wrong. It should be start and this should be start. And here it should be prefix sum of end because high and low will shift anywhere for doing the binary search. Let's try to compile the code again and check whether it's working fine. Let's submit the code. So yes, it's totally working fine. So the question was all about first make a linear search to make the two partitions. So this for loop is helping me to make two partitions. Okay. Now, now this binary search will helping me in again further two partitions with minimum absolute difference because I don't know which which better configuration can give me the partition. That's why I'm making two partition at every possible point so that I can check at every possible point which partition will further divide into two partition and get me minimum absolute difference. So in that way, you can say I am doing two partitions just in the brute force way. Okay. And this is the optimized way because I want to minimize the absolute difference within that partition. Within that one partition, we have to make two partitions. We can do it easily. Two partition question is very easy. But for four partition, you have to make two partition in the brute force way because you have no solution. Okay. So this was all about code. So if you like the explanation, please like, share, and subscribe to my channel. Thank you and have a nice day.